So we have the option of moving on now, taking a break now. It was 15 minutes. I think we should move on. And before the break, we'll try to explain, set the stage for the sections of survival analysis that we'll quickly go through. All right. So in the last 40 minutes or so, we have looked at time. We have looked at rate data. Okay. We have looked at rate data. But one other way that we are interested in examining rate data is, rather than look at the rate itself, we look at the time to the event. Okay, so rather than just say the number of events divided by time, in this case, we're going to say for each person, how long did it take for that person to experience that event? Okay, and then you look at that on average. So essentially, we're really modeling the time to the event, and then factoring in the fact that did the event occur or it did not occur. And we'll get to that in a moment. But to be able to get to that, the first thing we need to understand, I should say again that if you have questions, please use the Q&A to ask your questions, and Ibua will answer any questions, or otherwise I will also respond to them live. Okay, we don't have the chat function active today. I forgot to activate it. So all right, so first of all,
sorry, it's activated.
It is activated. Okay.
Yes. And can someone else confirm? I sent a message to everyone. Can you?
No, sir.
It works.
We can see your message, but we can't send the message.
They can't send. Yes.
Ah.
Yeah.
Okay. Okay.
Okay. All right. Someone has a question and says, "Is binomial regression a special case of Poisson?" Okay. So first of all, you can see that I am taking a deep sigh, because we have a little bit of, so what we have done in this class is that we've scattered around a number of issues. We haven't gone too deep. It's eight or 9 weeks. There's not so much that you can explain in that time. So excellent. It's good that you ask questions. So binomial regression, when you say a regression is binomial, right, it means that that regression is based on a 0 or 1. Okay, and a logistic regression is a type of binomial regression. Okay, now, but there's something called the log binomial regression. So sometimes, rather than take the logistic, which you saw as that rate of the proportions, whether the person had it or did not have it, we can just take the log of the proportion itself, which is the log of the binomial. So the log binomial regression is not a type of Poisson regression. The log binomial regression is used in the same context where you would use the logistic regression. The formulation looks the same because there's a group of models that are called general linear models. Again, they are called general linear models. And these general linear models is a long list of models. Pretty much everything that we have taught in this class to date, not everything, like all the regression models that we have taught in this class to date, all of these are types of general linear models. And there are other types of those general linear models. One of those types is the log binomial regression. Okay, you use the log binomial regression in the same time where you would use the binary logistic regression. Okay, what the difference between the log binomial regression and the binary logistic regression is this. Okay, so we're not going to go into much detail, but just to tell you, same thing is very similar to logistic regression. The difference between the log binomial regression and the binary logistic regression is that the way you interpret it. In the logistic regression, you interpret as odds. Sorry, my handwriting is terrible with this thing. You interpret as odds, but in the logistic regression, you interpret as odds. In the log binomial regression, you interpret as a risk. Okay. Again, logistic regression, you interpret as odds. In log binomial, you interpret as risk. And the way that you model it is slightly different. The code are very similar. If you're not paying attention, you might mistake them for each other in R. you know, but the log binomial regression is not as commonly used, in part because it runs into problems very quickly. Those problems are relating to like the confidence interval, so the variance. So sometimes when you run the model, you'll not get any results. And in those cases, you will use something called a log Poisson. So it gets more complicated. Okay. In the R lab, we go into those a little bit, you know, and just tell you that there are other types of binomial regression methods. The logistic regression, the log binomial regression, the log Poisson. You know, the log binomial and the log Poisson will give you a risk, but that's not what we're talking about here. So that's why in thinking about the name of the model, it's important to pay attention very carefully to, is this a log binomial regression, or are they just saying a binomial regression family of models? Or is this a log Poisson regression, or is this just the Poisson regression model, right? Because, you know, what they're doing is different and the names are different. There's also something called a negative binomial regression. So the names are very, you know, it can get confusing if you're not paying attention to exactly what it is. So in the last 40 minutes or so, we have looked at the Poisson regression, which is a model for the count or the rate. Okay. All right. So let's take a 5-minute break and come back at